Yes,
Ah,
yes, I am.
okay, good, good, good. Because I would like I would like to have a lesson not so boring, of course.
Okay.
And then I want to know what's your skill, and what else is online now? I see.
Archidius.
Hello.
Yeah, Arcadius, how you doing? Nice to see you.
Thank you. The same.
Are you? I believe that you are already Nitrox diver.
Yes.
That's good. Oh, guys, I'm recording the lesson, so then we will have also in the future, and then I will share with you the presentation I will going to use for our speech today. My goal is, of course, not to bother you and to make you to make me interested in these topics, also because as I see, you are already Nitrox certified, and then I would like to tell you some stories, some also some hidden part of the Nitrox industry, what we call, the technical diving, that is something related to that. Anyway, are we all connected, or is something missing? So I don't see. Oh, here. Marcel, Kevin, Arcadius. Is Sarah missing? Damien and Arthur. Do you know if they are going to attend? Arthur, Sarah, and Damien.
I will ask them. They should, maybe some
Oh,
of
thank
them.
you. Thank you, Marcel. Okay, Damien. Welcome, Damien.
Hi.
Hi, Damien. I'm Eugenio. Now I will introduce myself. Just a question, Damien. Are you already Nitrox diver?
Yes, I'm full trimix diver.
Okay, good. Very good. Okay. So it means that, okay, let's wait for Sarah. All of us are already Nitrox certified. Oh, just by curiosity, are you having any lesson in at the university, or are you still having everything online?
We do
We had
everything online.
done practicals.
Ah, okay, okay. So you start having something in presence. Good. So I don't know if Sarah will join us. She's the only one missing. Can someone text her or ask her if she's going to be with us? Please. You see the full screen? The Nitrox analysis screen?
Yes.
Okay, good. Well, okay, I believe that we can start. I hope Sarah will join us. But anyway, as I told you, I already started the recording of this session. So you may have, and then I will share with you also the PowerPoint presentation that I'm going to use now. So please, first of all, thank you for joining. It's a really big honor to me for me being here. And as I told you already, I don't want to bother you for, first of all, for my English, because I'm Italian, I don't speak a good English. I hope you can understand. If there is something that is not really clear, please stop me, and then I will repeat, or I will use other words. And secondly, if I'm bothering you, let me know that we talk. So I really don't like to have a lesson, online lesson, because I can see you in your eyes. You know, I can see if you are happy, if you are working, if you are interested in the topics. But anyway, I'll try to do my best, you know, for this. Anyway, let's go ahead with the presentation. Today we have two lessons. This one is today is the first. Next Wednesday we have the other one, and we decided to divide the NITROX lessons in two parts, because in the first part we are going to talk about what is NITROX. We are going to talk about the Dalton law, because most of you already know the Dalton law, that is not only important in NITROX, but is very important also in physiology, in everything that is done, you know, in the diving, also mainly for gas blending, you know, for producing. We will have also, I believe, next year, in the second part of the year, also the course of gas blending. So, because if I'm not wrong, you will have also the gas blending certification, and then we will talk deeply about the Dalton law and also the way of producing NITROX and the mix. Then. In my opinion, it's interesting part of the lesson is also the international norms and the regulation. That is extremely interesting, in my opinion, not only because you know, we talk about the law that are running, but because everywhere you go in the world, you find different regulation, you find different laws, you find different norms. And as a diving manager, or as a diving safety manager, you must have the knowledge of what is behind the regulation and how they apply to our industry, mainly because you will be in charge of your organization, and then you have to be aware of what does it mean and what is the topic behind the regulation and the norm. Then we are going to talk about NITROX analysis. We are going to talk about how to do the analysis, how to the analyzer works, and which are the different kinds of analyzers that are available. We are talking about the sensors, we are talking about the error and accuracy. We are going to talk about all that is related to the way of using the analyzers and the device for making a good NITROX dive. Then at the end of the day, of course, we will leave some part for the questions and to your curiosity, if any. But please, if you have anything, stop me and then place your question, and then I will be very, very happy to answer you. Next part, just a brief overview of the next part of the next week lecture. We will talk about the real how to do the analysis. So we will take the gas analyzer. We will take cylinders of NITROX, of oxygen, of other mix, and then we will do, you know, for showing you how to do. I'm sure you already know, but I would like to share with you some tips, some information, some, you know, hidden part that are not learned in the standard NITROX course. Of course, we will talk about the procedure, we'll talk about the accessories, and we will talk about all that is necessary for doing. Then we will dedicate more than half of the lesson to the practical exercise. So I will show you how to do, and in the reality, the best way of having an accurate reading. Okay. So, questions at this time? May I go ahead? Okay. Well, just for giving you my brief introduction, I'm Eugenio Mongelli. I was born in 1965, and I'm Italian. I'm a scuba diver since 1982. Now it's 50 years now, no, for 40 years now. It's a long time. And I was really attracted by diving for both free diving, fishing with spare guns, and also for just, you know, enjoying life underwater. 1991, I became an instructor, and since the 1985, 86, I started using a rebreather, mainly oxygen rebreather. That was the only rebreather available at the time, the military one. That I still use. As you can see in the picture on the right, is a funny picture that my friend showed to me last year when no, this year. This year when we were attending to a military show where we can use the oxygen rebreather for diving. So, and then we were there for a road show, and then also with our instrument. I founded in 1995 the DIOX company that we are involved in designing and manufacturing of gas analyzers. We started mainly with the oxygen analyzers because when we started, the NITROX was not so popular as it is now. It was banned from some organization like PADI, and there were no analyzers available. You know, with the only one that were available was the medical for anesthesia, and then we started designing something just for diving, just for with the necessity of the divers. Then I became in the same period also a NITROX instructor. I became a Trimix instructor, rebreather instructor, and I started also using the electronic rebreather at the time. But I would say that is my passion is diving, you know, and any kind. And then when I can be at the sea, that's my best part of my of my day. Then I also am involved in the diving market, also as in the commercial diving, in the saturation diving, in the military diving. So we have a view 360 degrees of our industry. So, and I'm very happy. I'm very proud to be part of the staff of this bachelor at the University of Malta. And this is extremely a very important and a very interesting project that I believe that will be also developed in other universities around the world. I was talking with Mr. Maroni about this. That will happen. Oh, also another topic. I was also involved in the Olympic Games organization, mainly in the broadcasting. That I worked in Athens, in Turin, in Beijing, Rio, in London. So I did many Olympic Games in the broadcast. It was extremely interesting for the organization and for the project management point of view. Anyway, okay. Let's start with NITROX. Okay, everybody of you know what is NITROX. NITROX is a blend, is a mix of air and oxygen with different concentration. I like to remind what Dr. Morgan Will said about nitrox. Dr. Wells was the director of the diving activity of the NOAA, the National Oceanic and Atmospheric Administration of the United States of America. That was the first organization that recognized nitrox as a beneficial mix for standard diving, for diving in a normal environment that were using that before was used air for doing this kind of mix. And nitrox is he was saying that Mother Nature provided Earth with a nitrox atmosphere that is known air, but he never said that it was the best mix for divers. And if you think, it's right, because air is available everywhere, it's cheap, it's easy to use for diving, but when you add oxygen on the mix, you have some advantages. I know you know everybody, but I know you know all these advantages, but I would like just to remind you. Mainly you have a longer time, diving time, bottom time, without the necessity of having decompression. You have generally less decompression if you exceed the limit for the compression, and when you use nitrox, you have less stress, less fatigue when you are using nitrox. You have a reduced narcosis because, of course, you reduce the amount of nitrogen, that is the narcosis gas, the narcotic gas we have when we use the mix. And also interesting, we have less interval between two dives if we use nitrox, because of course we load less nitrogen in our body when we use the nitrox. And of course, if you use nitrox using the air table or the air computer, diving computer, you increase your safety. I was talking before that some doctor also suggest using nitrox instead of air to the people that have some problem with the joints, they have some problem with the heart. So it's because, you know, using more oxygen under pressure is safer, and this is also, there are medical evidence on this, you know, that is this is why it is encouraged using we encourage using nitrox. And also for you, when you will be running your diving center, your diving organization, offering nitrox will add more safety to your organization. But on the other side, we don't have to forget that also nitrox have some cons, some problems. The biggest problem, of course, is the oxygen toxicity and the oxygen management, because first of all, oxygen cannot be breathed over a certain level, you know, the partial pressure of oxygen that we were going to talk later. The gas is the oxygen under pressure is extremely dangerous if not managed in the proper way. It's flammable and explosive. This part will be very, very well treated during the blending course. But I would like to tell you that because this is extremely important for you when you're thinking about organizing a nitrox facility or organize a nitrox diving with your customer or with your staff. And of course, a problem of nitrox is also the wrong mixing. Maybe can happen that some blender is not doing a good job, and then you have different mix. And if you are not able to detect, to mix, and mainly to analyze the gas in the proper way, you may have some problem. And of course also the improper use, because you maybe you go with deeper than is necessary or that is allowed with the mix. You may have some issue, some problem. Okay. So I don't see Sarah. Is Sarah with us? No, not yet. Okay. Anyway, may I go ahead, guys? Everything is okay? Hello?
Yes, yes.
Ah, okay. Sorry, Marcel, I said guys, but it's also a lady with us. Okay. Oh, just a brief story of nitrox in recreational diet. This is extremely interesting. In the navies around the world, the nitrox was already used since long time. Also in the hard hat, you know, the big old diving, it was used. In conjunction with air, because it was they saw, the doctor has seen that the life of the diver was better. You know, he was feeling less fatigue. He was less tired. And in the Navy, for instance, in the Italian Navy, it was used already the mix 40% oxygen, 60% nitrogen, or 60-40, 60% oxygen, 40% nitrogen was already used. This kind of mix for the also in open circuit in the scuba. So it was not something that was real, you know, new. But at the end of the 80s and the 90s of the last century, there were some organization, like the NTD or the TDI that probably you have heard, that was offering nitrox also for the recreational divers. And at the beginning, it was a big fight between this kind of organization, the technical organization, the agency, and the standard agency like the CMS or the PADI. And I remember that in the 90s, PADI itself banned nitrox as a mix that was dangerous. Don't use nitrox. They stated in the DEMA, in the first DEMA, this shown up this. After a while, luckily, seeing that there were no accident, there were no evidence of any issue, and the benefits are much more and higher than the cons of using nitrox, all the agency, PADI first, started offering nitrox course, starting training divers in using nitrox and encouraging also divers in using nitrox, because it was extremely good, you know, for doing that. Not only for the commercial point of view, for selling more license, but also for the point of view that physically that was an advantage. That was a lot of benefits in using nitrox. And now I believe that there is no diving center around the world that does not offer a nitrox. Maybe they don't have a nitrox facility, maybe they don't have a mixing panel, maybe they don't have, but most of the diving centers around the world have nitrox and offer diving. Myself first, when I go diving, when I go live board, or when I do something around the world, I like have nitrox, also because I'm not so young anymore. And then using nitrox helps you with your being less tired. That is the most advantage that I personally feel with nitrox. Mainly when you do multiple dive per day, you feel much less stressed, much less tired when you use nitrox. Anyway, I don't know. Do you regularly use nitrox when you go diving, or you prefer using air? Hello.
Well, speaking for myself, I use it quite often, nitrox, but I use whatever it's available, really. So I
Yeah.
use NITROX and
Correct. Yeah, that's another problem of the availability and also of the cost, because some diving center charge like €10, $10 per nitrox more, and that is simply something that really, okay, unless you have you live in a very far island in the middle of the ocean, that it's very difficult to get a cylinder of oxygen. Generally, oxygen now is worldwide available, is very easy to find, but sometimes you may have problem. And then don't forget, when you will organize your diving facility, remember also to check well how and where to find oxygen. Also, because nitrox can be also mixed using just air, with the membrane, with the filtering membrane. So you remove the part of the nitrogen of the air, and then you increase the amount of oxygen, and then you can do that everywhere you are in the world, just having this membrane. But don't forget that in this case you will increase the CO2 content, but we will talk later about this effect, side effect of the membrane. Okay, so I would like to start talking about the Dalton law. Dalton law is, I believe that you already knew, because we start hearing of Mr. Dalton since the first, the open water dive, in our course. But I would like to talk to you why this law is extremely important in nitrox and also in diving. Because it's have a lot of application. It's in the physiology, in the medicine, in the gas analysis, in the sensor technology, in the blending. There are very much application of the law. So what does this law say? The law says that the pressure in a gas containing different components like nitrogen and oxygen is equal to the sum of the partial pressure exerted by the individual components of the mixture. So it means that I have a mix with oxygen and nitrogen. The total pressure of the gas, what we read on our cage, is the sum of the partial pressure of oxygen and the partial pressure of nitrogen in that mix. And how we calculate the partial pressure of a gas component in a blend, in a mix of gas? The partial pressure of a gas is the product of the volume pressure of the mixture times the percentage by volume of the gas in the mixture itself. Okay, you can see here in the formula that PP, that is the way we generally use to say partial pressure of the gas, G, is equal to the total pressure of the mix, what we read on the cage for being real, times the fraction of the gas. Okay, and the total mix pressure is the sum of the mix of the gas that are the components of the mix. Okay, so if I have trimix, that is is a mix of nitrogen, oxygen, and helium, the total pressure is the sum of the partial pressure of oxygen, of partial pressure of nitrogen, partial pressure of helium. Okay, well, but let me try to let you understand the Dalton law in from different point of view. The partial pressure of a gas is the pressure that the gas would have if it occupies the entire volume of the mixture by itself. So if we were able to, in theory of course, to remove one gas from a cylinder of a mix, and then we remove, for instance, oxygen, the remaining part of nitrogen in the same volume will have the partial pressure meaning that the gas is is removed and then remains also its partial pressure, the part. And another interesting point of view is that a gas behaves as it were alone into the mix if we consider its partial pressure. Of course, if there are no chemical reaction among the components, because if there is a component, there are some components that have a reaction, like, for instance, okay, this is not something that we breathe, but if you use chlorine and oxygen, we cannot keep together because they create chlorine oxide that you don't have anymore a gas component composed by two components, but just by one, you know. But in case we are talking about gases like air or trimix that are not having any chemical reaction among. So, and this is, if you think this part is extremely important, because if you consider just the partial pressure of the gas, the component that is in the mix, like the oxygen or the nitrogen or the helium, you have the physical effect, the physiological effect, everything just related to the partial pressure. So you may forget totally the other components of the mix and just use the partial pressure of the gas. So this is good for narcosis, for instance. So you calculate just the part of nitrogen that you have in your mix, you calculate the partial pressure, and then you know at a certain depth which is the narcosis that you have. The same for oxygen, that is extremely interesting for your exposure, oxygen exposure. You just consider the partial pressure of oxygen, and with that mix that you have at a certain depth, and then you can calculate the effect, the physiological effect that oxygen have on your body, on yourself, you know, without considering nitrogen, without considering helium or other components. Also, okay, I forgot to tell you that in theory, we say that air is made by 21% of oxygen and 79% of nitrogen. That you know that in reality is not true, because we have 0.05% of carbon dioxide. Then we have 0.001% of argon. So we have other components in the mix. But for, you know, just for simplicity, just for making simple, we say that air is made just by oxygen and nitrogen, okay? But all the gas have their own effect related to the partial pressure. Of course, the smaller the partial pressure, the lower effect it has in the mix. And the partial pressure, the Dalton law, is extremely interesting if we want to, in the NITROX, if you want to calculate the best peaks, meaning which is the best nitrox that nitrox or trimix that I'm going to use for the depth I want to dive. Then, with the partial pressure, with the Dalton law, I can calculate the oxygen exposure. I mean, I can calculate the partial pressure at a certain depth, and then I can calculate which is the physiological effect, which is the dose of oxygen that I'm exposed. And then I can trim my dive related to this. And another interesting thing is the maximum operative depth. So it means that I can see which is the maximum partial pressure of oxygen that I can reach without having any bad effect. I believe that all of you know about the effect of oxygen under pressure. The oxygen effect under pressure have two main effects. One effect is related to the higher pressure, that is when you start breathing oxygen over 1.4 bar of partial pressure. If you go over, let me say, 45 minutes, 1 hour. and or there are other limits, you know, for that. And then that is the effect on your central nervous system. What you see on your computer, that is the CNS. You know, when you dive nitrox, the computer gives you this information. And then the other one is the effect of oxygen on the total body. That we calculate with the OTU, the oxygen toxicity unit. That is extremely important when you do hyperbaric treatment, when you do long time in breathing oxygen, that you may have effect on your lungs, you may have effect on your throat, on other physiological effect, also a headache, you know, other system like that. But I believe that you know very well the symptoms, and you know very well which is the effect of oxygen. So I don't want to bother you with this kind of information, but don't forget. And then the Dalton law is extremely important because helps you in having this evidence. Of course, everybody of us now are trained to use the computer, the diving computer. Diving computer is extremely user-friendly. You know, you just put the mix you are going to use during the dive, and then okay, provided you have analyzed in the proper way, you don't have any other trouble. You know, you just go ahead, you you put the concentration 32% of nitrox in the mix, and then you go. This is true, of course, but as already I say, as a diving safety manager, diving safety responsible, you will be, you have to know what is behind the computer, what is behind the partial pressure, what is behind the exposure dose. You have to know all this information. Okay. Now I would like just to remind you how to calculate, for instance, the maximum operative depth. If I'm not wrong, Vania. Oh, hello, Sarah. Hi. Hope you can hear us. Sarah just joined us. Oh, sorry. Sarah? I went.
Yes, hi.
Oh, okay. Sarah, just my question. Thank you for coming, and I'm sorry we started without you, but there is the recording, so you can see what we did, you know.
Perfect. Thank you so much.
No problem, absolutely. We are talking now about the Dalton law, and just my question, are you already NITROX certified?
Yes.
Oh, okay, so good. So you know what we are talking about. As I told your colleague, I don't want to bother you. You know, I'm just trying to make to give you some information that may be useful on your activity as a diving safety manager or diving safety officer, you know, in your diving organization. So, and we are talking about now the NITROX, the Dalton law. You know that, of course. You know, you already have studied. But anyway, just do an exercise together, you know, just for putting some numbers on the desk. You know that you know you go to the diving center and you ask to dive with the NITROX 32. That is one of the typical nitrox that you will be offered when you go diving nitrox. Then I will tell you why, you know. But the diving center gave you a cylinder. You do your analysis, and then you see that is 34%. So what you do? Okay, diving is easy, is nice, you know. Then you decide to go diving anyhow, even if you have the wrong mix. But what you have to ask yourself is how deep can I go with this mix? You know, can I use normally? The first thing you have to do is to set your computer to the dive computer to 34%. That is, of course, the easiest part. But you need to deeply understand that you have to calculate which is the maximum operative depth that you may use, meaning which is the maximum depth you don't have to go below for being in trouble, you know. Generally, we suggest not to go over 1.4, you know, the partial pressure of oxygen. And for calculating just applying the Darton law for calculating the maximum operative depth, you just have to divide 1.4 divided for 0.34. That is the fraction of the gas. Remember that when you see on the analyzer 34, that is on the display, you see 34. For your calculation, you have to divide per 100 because that is the percentage. So you have to do 1.4 divided 0.34, and then you have 4.12 bars. What does it mean? You remember the formula for going from absolute pressure to the ambient pressure in meters. You subtract 1, that means 3.12, and divide and multiply, sorry, for 10. So you have 31.2 meters. What does it mean? It means that the NITROX the diving center provided you, so the NITROX 34, you can use, but you don't have to go deeper than 31 meter, okay? And remember, always remember to stick to write, you know, on the tape or on the sticker, whatever, you have to write the maximum operative depth, that is in this case 31, and the concentration, that is 34, okay? Then it's better to put also the date and the signature, your signature, of who did the analysis, but we will talk later, you remember? Because mainly, okay, if you are alone, if you are doing your own dive in the diving center, there is no problem. But when you are dealing with 100 diving cylinder, NITROX diving cylinder per day, you must identify correctly the diving cylinder, and every cylinder must have its own tag, because it is extremely important also from the from the safety point of view that every mix, every cylinder is identified, is tagged in the proper way, because whoever will use must know what kind of mix they have to use. Okay, this is extremely important.
Sorry, can I ask a question?
Yeah, Kevin, please, absolutely, yes.
You mentioned that the partial pressure we should use is 1.4.
Correct.
Right? But isn't it suggested to use 1.6 if it's just as a deco bottle?
Yes, absolutely, yes. Thank you, Kevin, for this question. I mean, when we started using NITROX, we all were using 1.6. Even in depth, you know, because we were told that the higher oxygen concentration, the better was for diving, for reducing the time, and so on. But using 1.6 as a bottom mix partial pressure have some effects that cannot be well managed, so that all the agency, PADI first, decided to reduce the partial pressure of oxygen in depth, meaning below 20 meters, using the 1.4, you know, formula. 1.6 is still used, is still allowed for deco mix. So if you use the 50% or the 40% mix, you may use it for decompression and use it at 1.6. Also because these have benefits in a term of degassing when you desaturate for the inert gas, and they have also a physiological effect. But also it's interesting to say that is used, also is accepted 1.6 in decompression, because in decompression generally, you know, you stay, you know, you don't move, you don't have any, you know, any stress, so you don't have to use the fins so much. So in this way, you don't over stress your body, your central nervous system, and then the system can accept 1.6. But this is an extremely interesting discussion, Kevin. I would also suggest you, when you see Mr. Maroni, Dr. Maroni, to talk, because also, diving medicine is something that is a fluid. It's not written on the stone once forever. And there are some adjustments. I told you in the beginnings of NITROX in the 90s, everybody of us was using a 1.6 as a bottom mix, also in the bottom mix. But now it's better to reduce that, Kevin. Okay, did I answer your question?
Yes, because it was always suggested that if you're not doing any exercise, especially if you're doing deco
Correct.
on a rope or in the blue, it is actually more beneficial to use a higher percentage of oxygen from
Correct.
deeper, like from 1.6. So
yes, but
and I just wanted to clear this with you as well. So
yeah, right. But also because when you go deep, you are not in the compression, you are doing your dive, you may find tie-dye, you may find you may have to go in a different place, and then maybe you may have stress. So it's better not to exceed the 1.4, just because you don't know. Of course, if you go just diving, sit in a chair, you may use also 1.4 at the bottom, but you don't know what will happen. So that is okay. Of course, we have to give standard, and then when you have a standard, maybe you can trim in a different situation. You will have the ability, you will have the skills for doing this. That is extremely important, from your management point of view. Okay. Well,
thank you.
No, you're welcome, Kevin. It's thank you for interrupting me. Okay, now I want to talk also about the boring part about the norms, but it's not so boring, because it's interesting. Because wherever you go, if there is a local authority like the police or like the medical assessment, maybe you need to know what's happening in your place. In Europe, we have a norm, the EN 12021, that is an international norm, an ISO, that is used for the compressed air limits. It means that the norms gives you the standard for the air that have to be could be breathed in a proper way. In a proper way. There are many other regulations around the world. I will show you after a table of the American standard that is a lot. There are a lot. And then if you go to Thailand, there is another one. If you go to Australia, there is another one. If you go to Brazil, there is another one. Or there are some places there is none, like in Malaysia or Indonesia, there is no limit. So theoretically, they can breathe also the gas going out the engine, the exhale gas. Okay, I'm joking, of course, but this is something extremely important for you. The most important thing that you consider very careful the local regulation. If you are going to open a diving center in the Caribbean, you must know which is the regulation, the local regulation, because that's the regulation that will make you that you have to follow. In case you have any accident, in case you have any visit from the local authority, you must know what's happening, and you must be prepared, for providing the best service to your customers. Okay. In the US, the most used are the US Navy diving manual and the PADI specifications. In Europe, there is another interesting norm that is the UNI, that is the Italian norm 11366, that is the talk about the professional diving and hyperbaric activities. and in the service of industry, that is used mainly for the saturation diving, for the commercial diving, but it sometimes is also used for the diving center. You know, depends on the country where you establish your center. If all of you are in Malta, Malta mainly use the EN 12021, even if it's not a law, is not a regulation. It's just, let me say, something that is better to follow, because in case you will have any kind of accident, the first thing that the judge will come and see is, oh, which kind of air were you giving to the customer, which kind of gas, which kind of attention you took for your compressor, for the maintenance, and so on. And then the norms helps you in having the limits, in having something easy to use. Okay. Then on the side of the NITROX, there is also many regulation about the valves, about the cylinders, about the identification. So there are many, but never forget that a norm is not itself a regulation or a law. Understand? So a norm is just something written by a committee of technicians, of engineers, that sit around the table and decide to give some help. Then, in some cases, the norm becomes a law. For instance, in Italy, the UNI 11366 is a law, so you must follow this for the professional diving and for the hyperbaric activities. But the EN 12021 is not a law. You know, actually, it's just a regulation. So I hope you understand well this important difference between a norm and a regulation. But of course, if you follow a regulation, you are in a safer side. You know, if something wrong would happen in your diving center, in diving organization, having followed in a proper way, in the right way, in a skillful way, the norm will help you. Also because it helps you in understanding what we are talking about. Let's go deep in this regulation. What the norm says. The norm says that for providing to a diver a safe air, the air should have 21% of oxygen plus minus 1%. The carbon monoxide, you know, the carbon monoxide is a result of the incomplete burning of carbon, like hydrocarbon or oil or whatever, and must be as low as possible, but below 5 ppm, meaning 0.0005%, very small amount. We will talk more about carbon monoxide effect in the gas blending. But just for giving you a fast view of this, carbon monoxide is the most toxic gas that you may have. You may find in your diving career. So the lower you keep the carbon monoxide, the more scared you are of carbon monoxide, the best there is, because carbon dioxide just kills you, doesn't give you any chance. If you breathe carbon monoxide over 20, 30, 40, 50 ppm, you may start having problems that may lead to death. Don't forget, in Italy in 2014, we had a very big accident. 3 divers died in the same dive because they were breathing high amount of carbon monoxide, around from 600 to 2000 ppm. It was a very huge amount, just because the cylinder were filled in a compressor, and the compressor was close to the engine outlet, you know, and then the gas, the diesel gas, the exhaust gas went into the compressor, and then it was mixed into the cylinder. Just because you see what I mean, 5 ppm is 0.0005%. Is an extremely low amount, you know, that is extremely important. You keep caring of the carbon monoxide. We are very sensitive on this point, and I want you to be very sensitive as well. You know, protect yourself, protect your organization from carbon monoxide. Okay, then the norm, the EN 12021, also gives other part, that is the carbon monoxide, that don't have to be below 500 ppm. And being honest with you, it's very difficult to get this, because if you're in Malta on the sea, no problem, it's 300, 400. But if you are downtown Milan, like I am now, we have around 1000 ppm, you know, in the air. So if I fill a cylinder here in my office now, I will get an air that is not compliant to the norm, and then I would be in trouble. Luckily, 500 ppm means 0.005%. 1000 ppm means 0.1%. That is a very, very below the limit that you have physiologic problems, you know, because carbon monoxide problems, you start having over 20,000, you know, of carbon dioxide. So, but keep caring of that, because carbon dioxide is something that is increasing. When I started this job, the carbon monoxide was around 300 ppm in air. Now we are 600 in the average. This is why, you know, we are we try not to use the fossil fuel anymore. Anyway, the other part is the oil. Oil vapor must be below 0.5 milligram per cubic meter. That is also, this is a very, very extremely low limit. And then now I'm talking from the point of view of the manufacturer. And when we manufacture the sensor for the oil, is very difficult, because you have to use a very, very, very sensitive sensor, and of course expensive, you know, for providing the right accuracy. Then there is the odor and the taste that when you breathe, you don't have to have any kind of effect on your nose. The water vapor must be below 50 milligram per cubic meter if you are breathing up to 200 bar cylinder, or below 35 milligram per cubic meter if you are breathing at 300 bars. Why, you may ask yourself, we put limit on the water, you know, water doesn't kill. Correct, water doesn't kill anybody. Keep caring in your diving center. The humidity is just something that is created because the compressor, the draining system of the compressor is not working well. If you have an increase of water, it's because the filter system and the compressor is not working well. You have problem with the water in the cylinder for two reasons. The first reason, that is worldwide, because if you use the cylinder, the steel cylinder, the water below may create rust, so may reduce the life of the cylinder. And if you use the air in polar, if you are in Norway, Sweden, or in the Antarctica, having a high amount of humidity may block the regulator when they use, may block also the valves. So this is why it's extremely important to keep caring also of water in this kind of environment. But just for giving you an idea, because, you know, talking about 5 milligram or 35 milligram doesn't say anything. 50 milligrams at the ambient pressure and ambient temperature is around 0.01% of relative humidity. You know, the relative humidity that you measure every day, you know, you see when you see the television, the weather, they speak also about the humidity. Now in this room, now we have around 50–60%, you know, and then in the amount of water is the equivalent of 0.1%. This is extremely low amount. It is also difficult to measure, of course, being back to my my company and to the importance of to detect so low. But another important point is the EN 12021 that talks also about the requisites, I mean, which is the content of air to be blended with oxygen for having nitrox. And the norm gives you also this limit, and also for being blended with the helium for making trimix. So you understand the importance of this norm, you know, because have a range of application. So, and then if you apply this kind of norm or regulation in Europe, even if it's not a law, is extremely good for you. You know, you are in a safe side if in case of any authority assessment or in case of any accident or problem that may happen in your diving center. Okay, and this also helps you for maintaining in a proper way the compressor, the air compressor. The US Navy diving manual and the PADI standard have more or less the same limit. They have just a bigger limit for the carbon monoxide, it is 10 ppm, and a higher limit for carbon dioxide. This is extremely interesting. This is a very, very good point of view from the American that are very, very practical, because 1000 ppm is easy, is being below. As I told you, if I feel a cylinder here in Milan, now in my office, I don't have air that is compliant with the European norm. But if I apply the US Navy or the PADI standard, I am, because I am below 1000 ppm. Okay, just forget this kind. But okay, I told you this is not a physiological effect, doesn't have a problem, but is below. Oil is 5 milligram per cubic meter. That is a small higher, and no taste, no odor, of course. And the water is around 24 ppm, or dew point below 25 Fahrenheit or 54 Celsius. That is just another way of measuring humidity. Humidity is sorry for my English, is a mess for measuring, because there are the one that measure the dew point. The dew point is the temperature in which the air starts giving you the first drop of water. It happens when you take out a bottle of beer from your fridge in summer, that you see that around the bottle you have the bubble of water. You know, that is because the temperature is below the dew point. But more or less we are talking about the same amount or of 21, 25, 26 milligram per cubic meter, 0.1% of relative humidity, more or less. And also there is in the US Navy, there is also the VOC, that is the volatile organic compound, that is typically what we use for measuring the hydrocarbons and the oil mist. So it's generally we use the VOC, also VOC sensor, you know. Okay, this is a dive table that, of course, I want you to learn. No, I'm just kidding you. You know, it's impossible. But just for showing you how many regulation, how many type of air is in the US. This is just a table that collect all the different regulation in the CGA. That is the Compressed Gas Association, or the OSHA, that is the Fire Brigades organization, or the Navy, the medical application. Okay, there are these standards. So my message to you, of course, is not to learn to memorize this big table, but just to know, to be aware that everywhere you go, you have different regulations. So wherever you go, just inform yourself on what's running on your place. This is extremely important. Okay. Well, guys, we go ahead now and we talk about the analysis itself. Is there anything that you want to talk more about, the regulation, the norms, the EN 12021? Okay, so I go ahead. Let's go and let's see now.
Yes, so, sorry, I have,
I
have one question.
Please.
So the norm is for the breathing air.
Correct.
So for the oxygen, when we mix nitrox, we are normally using another norm.
No, I mean, the EN 12021 also gives you the limit of the air to be mixed with oxygen for blending. So if you use an air that contains below 5 ppm of oxygen, of carbon monoxide, below 500 ppm of carbon dioxide, below 0.5 milligram per cubic meter of oil, and 25 milligram of water, this air is compatible with oxygen. Understand? So this is extremely important for you, because having an air, a safe air, you may mix with the pure oxygen with no problem. Understand?
I'm clear on that point. My question actually was, for the oxygen, we are mixing with the air when we are doing NITROX, when we are blending NITROX, so to say.
Correct.
Is there another norm for the oxygen?
Yes, there are many regulations, but that is for handling oxygen. Okay, and this norm will be taught during the gas blending. Okay, if you want, Arthur, just send me a private message, and then I will send to you the norms that may be used. But we will talk about this norm. I told you next year in the next part of your course. Okay, we will cover also this, because it's extremely important. Thank you, Arthur, for this question, because it's extremely important, not only because the local regulation, the police that may come, blah 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 blah, but also for your safety. That is the most important thing. You must follow this rule for working well, for being safe in your diving center, in your diving organization. Okay.
One more question.
I have one too.
Kevin.
I think Arthur has another one before me. I don't know. Go ahead, Arthur.
If you don't mind. Can we say the same thing for the helium we mix in?
Yes. Also helium. The helium has the advantage that it doesn't have any problem with deflagration or explosion. Helium is just asphyxiant gas, because if you breathe without oxygen, you die, because helium doesn't have any effect. But helium is a total inert gas, doesn't have any problem, any effect on the on your body, and doesn't have any effect on the gear. So you may use any kind of equipment, any kind of media, any kind of hose, any kind of grease, everything you want with helium, you don't have any problem. Okay.
But maybe if it has impurities in it, it might affect. Yes.
That's another issue, of course. That's another issue that we will talk also in the gas blending. I would like just to tell you something. I tell you now because I cannot stop saying that. 2 years ago, I had my Russian distributor that sent to me a text saying, "Thank you, Eugenio, thank you, you saved my life." Why? What happened? I tell you the story. I cut the story for you. They were using helium coming from the cylinder. They were using helium for melting, for blending, trimix, for a rebreather dive. They had to go 150, 160 meters. What happened was that the cylinder that was used for helium was used before for containing argon. Okay, you say argon is not a problem. No, argon is a big problem if it is mixed with, it's a mixed for soldering, for using as a solder gas, because they use 1% of carbon monoxide inside. And this cylinder was not well drained when they refilled with helium, and the carbon monoxide inside the cylinder was 1000 ppm. So when they blended the trimix using that kind of helium from that cylinder, they put inside 300 ppm of carbon monoxide. Understand? It's extremely important that you detect which kind of helium you use. Correct, Arthur. Okay.
Thank you.
Kelvin.
So my question is, does this cover any mix? Because we're saying that this covers any NITROX mix. So
yes.
If these are the levels, then you can mix oxygen, pure oxygen, with air.
Correct.
Does this cover any mix? So I can mix 80% oxygen with 20%.
Correct.
This
Correct.
these regulations cover any kind of mix.
Any kind of mix, correct. Any
Okay.
kind of oxygen and nitrox and trimix. You know, if
Okay.
you have the full norm, the norm gives you all the rule, and that is good, you know, because you have a standard and you follow, and then you are in a safe safe side. First, for your safety when you blend, and secondarily, in case you have an assessment from the local authorities that you can show that you are following the norm in the proper way. Yeah.
Okay, thank you.
You're welcome. You're welcome, guys. Thank you for your questions. Okay, now let's talk about the analysis, the nitrox analysis. Okay, for doing the nitrox analysis, you need an analyzer, a gas analyzer. You know, this is a typical oxygen analyzers. You know, that makes you have the amount of oxygen that you are going to use in your system. Now the unit is making the self calibration. I don't know if you can see. Yes, you may see. Now it's 21%. Okay, why we talk about nitrox analysis? First of all, because it's a mandatory. All the standard say that you have to analyze your nitrox. You have to analyze your oxygen content inside your cylinder. The oxygen analyzer is the easiest way of using that. It's extremely important for your dive plan. Because if you don't know exactly which is the content of oxygen in your cylinder, you cannot dive. You remember I told you before when we were calculating the maximum operative depth of 34% oxygen nitrox, you know. What is the plan? Because I was planning to use the 32%. Why now I'm having 34? What should I do? And then you have to know what to do. Then is a safety. Of course, because if you made a mistake, if your diving center made a mistake, your gas blender made a mistake, and for instance, gives you a pure oxygen cylinder instead of air, I tell you that happens. You must analyze for knowing what's happened. Also because it's your personal as a dive manager, you are responsibility of the diving center, and as a personal of the owner, of the user of the cylinder, responsibility of knowing what they are going to breathe. I just want to tell you another story. You know, 3 years ago, we were attending to our yearly dive show with the military in Austria. We ran that in September. We just had that, and we had an accident. We had a diver that was submerging. Immediately, he was fainted. You know, he was not in good shape. The strange thing that he was using an oxygen rebreather. You know, oxygen rebreather. It's very difficult that you faint unless you have, you know, that the filter is not good or something like that. Luckily, nothing happened because the guy immediately went back and then he just had to spend one night at the hospital just for check, but it was okay. He didn't have any problem. So we went through what was happening. So we dismantled the rebreather. We saw what was inside. We checked the filter. The filter was good. He told us that he were doing properly the purge of the loop. And then, okay, I said, but why don't we analyze the gas? The gas in a pure oxygen rebreather, you think that you have a pure oxygen, you know? Then when we analyzed, we saw that it was 80% of oxygen, not 100%. This is why he had the accident, because the concentration, the partial pressure of oxygen into the lung was not enough for sustaining his life, you know. And you know why did it happen? You know, because you say, okay, this is pure oxygen. I'm using a booster for pumping from the low pressure cylinder of oxygen cylinder to a smaller cylinder of the rebreather. How it happened? It happened because it was the booster that have a leakage of air with the driving gas, that is air, into the circuit of oxygen, and then at the end they had a cylinder with 80% of oxygen, not 100%. So you understand how tricky it is, because they didn't do the analysis. And from then, all the diving activities, all the diving organization, the military that use the pure oxygen are obliged to analyze the gas. Maybe it won't be 99.9%, maybe it would be 95, 96, 97%, but at least they know that is oxygen, pure oxygen. So understand, never underestimate the necessity of of using the analyzer. Okay. Well, the analysis must be done. Okay, I say always, but what does it mean? Means during the filling or the blending, when you have to give the cylinder to your customer. When you take the cylinder and then you have to put the tag, you have to identify the cylinder, because you are responsible to first to deliver the right gas, and then you are responsible to see that your customer, the client of your diving center, correctly have a check himself. So he must be aware that you are giving him the right mix in a proper way. Understand? This is extremely important point. Don't underestimate, never, because you have seen what happened to the military. In a very safe environment, in a very safe and controlled system for delivering oxygen, etc., that was the accident. Understand? And be extremely careful. Okay. Then, of course, it is necessary to analyze before refilling, because if you have to top up. Mainly, this is something important when you use helium. Now, you know, helium is extremely expensive, and then when you have a half cylinder of helium, of trimix, is not a good idea to drain totally, to put in air, and then to start refilling from 0 bar. You know, you need to use use the helium that you have, and then if you don't have an analyzer, you can do the proper topping. You know, you cannot do the right mix. So this is why it's extremely important, the analysis. And also, of course, it's a what if. So what happened if the rebreather diver found that there is not pure oxygen, but is 80%? What happens if I have a cylinder that I ask the 32% and I have the 34? So you have to you are able with the analysis to manage the different scenarios that you may have if you have a wrong mix, or if you have a mix that is not properly filled as you require. You know, you can ask for a new one, or you can, that is what we generally do, replan our dive. You know, we reschedule and then we do whatever we need to do for the gas. Okay. Well, about the analyzers, it's extremely interesting when you choose an analyzer for your diving center. There are many technologies available, many products. Luckily, we are not in the when we started our activity that nothing was available, so we had to invent everything. Now there are many brands that offers good products, and but mainly you need to choose two things that are the most important: the display, how big is the display, how visible is the display, the color is useful to read, and the sensor. So the higher quality the sensor, the better analysis you have. Then, of course, there is also the color, there is the location of the sensor, inside, outside. Then you have to check also the pressure, the temperature, and the humidity, because, of course, when you measure gas, these are the parameters that you have to use. Then there are monogas or multi-gas analyzers. So there is analyzers with helium and carbon monoxide with oxygen, or there is a multi-gas analyzer for oxygen, helium, CO, CO2, humidity, oil, and everything, you know. So that's up to you, depending on your organization, on the budget you have, and then you can go for the different products. Never forget that the sensor is the core of the device. Now I show you.
Can I ask you another question, if you don't mind me interrupting you?
Yes, please, Arthur.
When we were speaking, I don't know if you mentioned it already. When we were talking about the quality of the air,
yes.
So the oil mist, do we measure it with the volatile organic chemical one.
Correct.
All right,
Correct.
okay, that's all.
We
I
use
wanted to
that
clear
because-
that out.
Yeah, no, I tell you why. So you ask me where in the university I can be more specific on this. We use the VOC because the oil have what we measure is not the oil itself, but we measure the vapor of the oil, because the oil, the volatile organic compound have a vapor because evaporates, and then the sensor smells this vapor, understand? And this is the better technology because the sensor that we use now is a photoionization device, and they use a lamp, ultraviolet lamp that makes an ionization of the vapor, and then they measure this ionization, you know, and this is extremely useful. And then when we will be meeting, I hope I will show you just with the analyzer of oil, and just putting on top of a bottle containing the draining water of the compressor, you will see the analyzer beep 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 going to alarm when they breathe, you know, the content of the bottle. Understand,
Yes.
Arthur? Okay.
Very
So,
interesting. Yes.
anything else? Something else? Okay.
No, that's the question. I know you mentioned something about it. I just wanted to.
Yes,
have
thank
more.
you, Arthur. Yeah. But of course, we will talk also about this on the blending. You know, we will go more in specific. Okay, this is a sensor. This is an oxygen sensor. Oh, I give you one. Generally, the sensors are delivered in a closed can. You see, and the sensor is a cylinder like this. You see, the sensor is the core of the instrument. The higher accuracy, the higher quality, the higher the better is, of course. It's better to use a medical sensor, medical grade, because they have also they are subject to a lot of different regulation on the medical device. So when you use this kind of sensors in your organization, we are on the safe side, because in case of any accident, you may prove that you use the best possible technology. And of course, the sensors are reliable, they have a warranty, they have a good accuracy, and so on. There are many sensors technologies. There are the diving sensors, depending on the membrane that is here, the media between the gas and the electrolyte inside. They work like this kind of sensor, electrolyte, electrochemical. They work like a battery. You know, the oxygen goes inside here, make a reaction with the hydroxy the KOH, the potassium hydroxide, and they have a current, a very small, very tiny. We are talking about nanoamp, you know, very small. That is amplified, and then you have the signal. And the nice thing is that the sensor is sensitive to the partial pressure of oxygen, not to the fraction. I'll talk to you later about this difference. Okay, then there is other technology, that is the zirconium, there are the optics, there are the paramagnetic, and there are new technologies that's going also. There is a mirror, then there is some device, some sensor for laboratory, some other for wrong environment, for strong environment like the refinery, oil plant, and so on. But generally, on the diving, we use the medical, that is the best. Just let me introduce you shortly the optic sensors. That is a technology that is going out. I don't know if there is any rebreather divers among you. Poseidon is offering in this 7 rebreather an optic sensor. The sensor optic technology is a good technology if you arrive to 25% of oxygen, that are mainly used in the automotive when they have to measure lack of oxygen in air. So they need to know if the engine is working well, is using all the oxygen in the air. That is the goal, you know, of the engine. The optics have the advantage that they have very, very long lifetime, is not affected by other things that are affected, but the problem is that cost 30 times a standard electrochemical sensor. So that you have to be careful. The sensor, don't forget, it is differential, not absolute. What does it mean? Means that it measures only a point, and then if you don't give him another point, that is the calibration point, the measure won't be accurate. So this is why you are taught when you start with your analysis, you have to calibrate. You know, there are the system like this that is automatic, that you just press and then you have an automatic calibration. Otherwise, there are the trim that you turn for arriving at 21%. So you say, hey sensor, in this moment you are 21%. Now on, whatever value I read on your sensor, that is the difference that it measured to me, which is the concentration. Okay, so it works this way. An interesting thing is also the error, because the sensor have the error. Generally, what is required in the NITROX is the 1%, meaning that 1% of full scale, meaning plus minus 1. So if you read 32 here, the sensor, if the sensor says you 32, the mix may be 31 or maybe 33 in the bigger scale, you know. So we would be in between these two values. Okay. Of course, the more accurate is the calibration, the better accuracy you will have in the measure. The closer you go the calibration, the higher accuracy you will do. But we will talk this on the next lesson. Next lesson where we do the practical way of measuring the mix, you will see this. You know, we will talk about this. Another interesting point is the repeatability, because if you do the analysis of the same cylinder 2 times, for sure you will have different reading. I don't know if you ever tried, but it's normal that when you first do the analysis, then you do after 5 minutes, you have a different. Why, you ask? Because there is a difference in the temperature, mainly. There's a difference in the pressure, because don't forget that the sensor is sensitive to the partial pressure. And of course, the reliability of the sensor. There are many brands of sensors. Better if you choose the high, high quality, because you are talking about your life. And also, the sensor is sensitive also to the pressure of the ambient. If you are sea level, if you are in mountain, if you are in a depression, you will see a difference. So if you give now this that is calibrated 21%, you go in a mountain at 3,000 meters, you don't see 21%, but you will read 16% or 15%. Not because the air is a lower concentration. The concentration is always 21%, but the unit measures the partial pressure. And don't forget that the partial pressure is the product of the total pressure, the ambient pressure, with the concentration, with the fraction. And if the pressure is lower because you are in a high mountain, the partial pressure is lower. Okay, this is extremely important point. Okay, so I say that we finish this part today. We are more or less in time. Yes, it's 1:26. So we just had a talk about the Dalton law, how important it is. We saw the application of the Dalton law in the physiology, in blending, in the physics of our sport. We have seen the importance of the norms and the regulation. We talked about the NITROX analyzers, and we talked about the oxygen sensors. So, guys, I invite you to revise this lesson if you like, and if you have any kind of question, please feel free to come back to me. You know, just send me a text on Team or send me an email. Now I will send you my personal email, so you will reach me if you have any other question. Guys, is there any other question that you want to place?
I will send you a question by email, not to take
Okay,
the
Damien.
time.
Thank you. Thank you. I really appreciate
Thank
it.
you.
And feel free, to use myself for this kind of information, because I have a long experience in the gas analysis. I've seen a lot of situation, and then I'm very happy to share my knowledge, my skills with you. With no problem. Okay, so
Thank you.
thank you, Damien. Anyway, if there is any other question. Okay, the lesson is recorded, so you may access the recording of the lesson, and then I will send you also I will send you this presentation. So I will share I will put in the common part so of this group, and then you may download, you may use it. Okay.
Thank you very much.
Thank you. Thank you.
See
Thank you.
you next
Thank
week.
you.
Thank you.
Bye bye. Have a good day.
Thank you.
Bye.
Can
Thank you.
I have a
Thank
quick
you.
word
Bye-bye.
with you, please?
No, sorry. Go ahead.
No problem. No,
Arthur.
what I wanted to talk to you about, because I was planning on making my dissertation on the gas mixing and
Okay.
so on in the
Good.
dive centers. And I was wondering, maybe because we have to think about choosing a tutor. And I
Correct.
was wondering maybe if you would be willing to be my tutor for the dissertation, maybe.
Yeah, I believe I can. There's no problem. Just talk to Vanya and
Okay.
and tell her what you like to have, and then I will be very happy to help you in this topic. Okay?
Thank you very much. I thought,
You're
let
welcome,
me put
Arthur.
it through you first, because actually but since you are, I work with the dive warehouse, Claude.
Oh,
I
good.
think you spoke to him earlier this
Yeah,
week. He told me
yeah.
about
I
the
did.
jobs as
I
well.
talked to him. Yes. I'm very happy, really, Arthur. If I can be helpful for you, I will be very happy. Okay.
I think it would be good for me since I want to do it on gas quality in
Yes.
the diving centers. That
Correct.
obviously, with your experience, you have a lot
Correct.
to offer me. Okay, I
Yes.
thank you very much. I won't
Thank
hold
you.
you anymore.
You're more than welcome. Thank you, Arthur. Have a
Thank
good
you.
day.
Thank you.
Bye.
Okay, bye.